Thanks for coming back to this second part of A-Level Maths Mechanics, Modelling in Mechanics. Let's now look at what units and quantities are typically used. First quantity is mass, measured in kilograms, and it's given the symbol m. Length, a distance or a displacement, is given the symbol s and is measured in meters. Time is given the symbol t and is measured in seconds. Speed or a velocity is given the symbol v and that's measured in meters per second. And of course, speed and velocity is essentially how quickly an object moves a certain distance within a given set time, say per 1 second. Acceleration, this is how quickly an object changes its velocity. It's given the symbol a, and the units are ms to the -2. And finally, force, which is essentially a push or a pull, is given the symbol F and it's measured in newtons. Let's take a closer look at forces and the different types of forces we can get. The first one is a frictional force, and this occurs between two rough surfaces as they move over one another. So in this example I've drawn, we have the car that is going to move forward following the red arrow. As the car moves forward following the red arrow, the tyre moves over the grass, and there is a friction between the tyre and the grass, and that frictional force you can see is acting in the opposite direction to the forward motion of the car. All objects that have a mass will have a weight, a force of weight that acts vertically downwards in the same direction as gravity. A normal reaction will act when an object is in contact with a surface, and it will act perpendicular to that surface. So here we can see the tram sits on its rails at an incline, and we can see the line of the incline there in purple, and the reaction force acts at right angles up through the tram at 90 degrees to the surface of the road. Tension is the force used to pull a string or wire tight so it's not slack. We can see in the diagram here that the wire of the violin has a force of tension pulling to the left and an equal and an opposite tension pulling to the right of the same string. When an object is propelled in some way by an engine, the force that is produced is a thrust. So in the example of the space rocket taking off, we can see that the thrust is directly upwards. This is caused by the explosion of the rocket fuel in the rocket's engine. In the aircraft, in the right diagram, we can see that the engine is producing a sort of an exhaust, which is creating a haze in the photo. And we can see at the back of the aircraft there is a sort of an orange glow. This is coming from the exhaust. What's happening here is that the aircraft's engine is pushing hot gas out the back of it, and this generates the thrust that moves the aircraft forward. Compression is when an object is squashed. Here you can see that the rock has squashed or crushed the car. The rock is providing a force of compression on the car. Buoyancy is a floating force. In this case, the water pushes up on the tub to keep the tub afloat. Here we have a parachutist following the line of motion drawn on the diagram. Trailing behind them, they have a Romanian flag, and the Romanian flag allows us to show the direction of the air resistance. It's a very good demonstration of air resistance. And what we can see is that the direction of the air resistance is in the opposite direction to the motion of the parachutist. So air resistance will always act in the opposite direction to motion. When we model mechanics, most of the examples will exclude air resistance when we're solving our problems. This makes it a little bit easier to solve the problems. However, we need to be aware of the fact that we have chosen to exclude air resistance when solving our mechanics problems. Mass and weight are frequently confused. There is a difference. The mass of a body is how much matter it contains. The weight of a body is a measure of the force the body produces when in gravity, gravitational force field. The mass of the body, or how much matter it contains, is unchanged regardless of where it is in the universe. However, the weight of an object, its force, depends on which gravitational force field it is in. Therefore, an object cannot change its mass, but it is possible for it to change its weight. For example, an object of 2 kilograms mass would have approximately 20 newtons weight on the Earth, but only 4 newtons of weight on the Moon. Let's now finish off the topic by looking at the differences between scalar and vector quantities. I'm going to start this by drawing a grid. And I'm going to say that Alan stands here and Bob stands here. Now, this distance here is 4 meters, and this distance here is 3 meters. So this is our x direction horizontally and our y direction vertically. Now, by Pythagoras, we can see that this is 5 meters. So the distance between Alan and Bob is going to be 5 meters. And that is a scalar because it basically says how long or how far the distance is between Bob and Alan, or Alan and Bob. Now, if we wanted to describe the vector that takes us from Alan to Bob, we would go along 4 meters and then up 3 meters. So the vector of Alan to Bob would be 4i plus 3j, where I is the vector for the x direction and j is the vector for the y direction. Now we can see here that this is different because it says how we get from one place to another. It gives us a direction of how we get from Alan to Bob. If we go from Bob to Alan, we can see that the direction is also important. To go from Bob to Alan, we must go down 3 meters, so that's minus 3j, and we must go back 4 meters, so that's minus 4i. So to go from Bob to Alan, our vector is minus 4i minus 3j. So we can see how our vectors give us the size and the direction. Thanks for watching the past 2 videos on modelling in mechanics. If you have harder questions you would like me to answer, please join us at kippersconsultancy.co.uk, where you can book lessons, meet students and tutors, have your harder questions answered, build up your confidence and access higher grades.